You watching it now too?
Yeah, where are you watching it?
What?
Where are you watching it?
I was watching it on CNN. Okay, on my YouTube TV. All right, let's get through this. Kevin, lower that for a few minutes, or wherever that's coming from. All right. Again, same thing as last couple of times. I don't want you guys, or I need you guys to take any notes. You guys will come back and answer some questions after we're done with this. This is basically the last part of the unit. Okay, Thursday's lessons is something a little bit different. Ties into everything that we're doing. This is really the last part of all the vocabulary and stuff that you guys need to know. And you guys probably already know a lot of this stuff already. So I'm not going to spend too much time talking about some of these differences. First, at the end of this unit, you guys are going to do a run an experiment or do a study, like a survey. Okay, one or the other, and you can do either. But there's two different types of studies, and when you guys do this, one is called observational study. Pretty simple. You're just observing. You're just collecting data. You're not manipulating anything. You can't prove one thing or the other if you're just doing an observational, right, Noe? You can't prove a cause and effect. You can only prove that there's an association between two things. But if you actually run an experiment, okay, then you can actually prove a cause and effect relationship. If I wanted to figure out how much sleep affects your guys' grades on the next test, I could just ask you how much you got sleep on Monday night. The test is on Tuesday. I can see what your grades on the test were like, and I could tell whether or not the grades were affected by how much sleep you got, right? Would I be able to prove that sleep actually caused you to do a good or bad on the test? No, there's a lot of things that go into that. Did you study? Were you prepared? Did you eat breakfast? Any of those things. Now, if I manipulated something, let's say I made half of you guys listen to music during the test, and I let half of you guys not listen to music. Then now I'm manipulating something. That's an experiment. That's an experimental study, okay, not an observation, because I'm actually changing something. I'm actually manipulating something. I have a really short video you guys can watch real quick. That'll kind of explain some of that difference to you.
With the two main types being an observational study and an experimental study. In an observational study, the researcher observes happenings and measures characteristics of interest and tries to draw conclusions based on the observations. The researcher observes part of a population but does not influence or change existing conditions. An example of this would be a researcher observing driving patterns on busy city streets. In an experimental study, the researcher manipulates a variable and tries to determine how the manipulation affects other variables. For instance, a researcher may have two groups, a treatment group and a control group, and take the resting heart rates of each individual of each of the groups. The treatment group can be given specific instructions, maybe take a 30-minute walk every evening for 4 weeks, and the control group can be told not to change their normal evening routine for the same next 4 weeks. After the 4 weeks are up, the researcher can check the resting heart rates of each of the individuals of each of the groups to see if there were any differences between the groups. So in this case, the researcher manipulated the variable of physical activity to see how that manipulation affected the variable of resting heart rate. All right, my friends, I have more videos right there for you. Till next time.
Pretty simple. You got to manipulate something in order for it to be an experiment. All right. Do you need me to discuss any more about the difference between observational and experimental? It's pretty simple. That's the easy part. Let's dive into a few more details, guys. I know some of you guys are working on different things. Give me a few minutes of your time for some of these, because this is new to you. You probably have done experiments in science before, but you haven't used these terms. And I'm going to give you the three terms that I have right here. Talk about the three different variables. Okay. First is the explanatory variable. Explanatory variable is what we manipulate. Okay, if I manipulate something, if I was going to see if music helped you guys do better on your test, what am I manipulating? I'm manipulating whether you listen to music or not, or the type of music that you listen to. Okay, that's the explanatory variable. My response variable is what we're going to measure at the end. If I was using music to manipulate to see how well you guys do on the test, what's the response variable? What am I measuring at the end? What's the only thing I can measure after you take your test? The grades on the test. That's the response variable. Okay, so that's how you do that. Confounding variable is something that, hey, I didn't manipulate or I didn't control, And now that could have also affected your grades on the test. That could have also affected the response variable. What else, and we just talked about this, would affect your grades on the test besides just listening to music or not listening to music? Whether you studied, whether you got a good night's sleep, whether you ate breakfast, all these different things. Those are all called confounding variables. They could affect the response variable. They could affect your grade, but I didn't control them. I could have told all of you, go to sleep by 10 o'clock. I could provide breakfast for you. I could do those things to control those confounding variables. But if I don't, then something else could have actually caused my thing as instead. So let me give you a couple of examples. Do you guys know what sleep apnea is? Does anybody know what that is? How many of you have parents that snore like really, really loud? Parents might have sleep apnea if they snore really loud. Yeah, my dad snores. My dad spent the night this weekend. He came into town. He lives in Houston. And my dad snores like the walls just rattle. Like he snores so loud. All right. Sleep apnea is people have problem breathing while they're sleeping. That's why they snore. Okay. And so there's a study of more than 8,600 people suffering from sleep apnea that talks about, well, these people might develop diabetes as well. They collected data from 8,678 adults who were diagnosed with sleep apnea and found they followed them participants for X amount of years, and they found that 11.7% of those patients developed diabetes. All they did was watch them, okay, and see if they had sleep apnea and developed diabetes. Why is this observational and not an experiment? They didn't do anything to them. They literally just observed them. They literally just observed them. There was no treatment. Okay. I didn't try to get them a healthier diet or anything like that. We just observed. Because of that, can we conclude that sleep apnea causes diabetes? What's the simple answer? Yes or no? No, we can't. Okay. If it's not an experiment, we cannot prove that's one thing causes the other. This is just an association. And what else could have caused people to develop sleep apnea or to develop diabetes? Do you guys know what diabetes is? Okay, so what besides sleep apnea, what usually causes people to be diabetic? Too much sugar. So possibly they have a poor diet, overweight. Okay, these things lead to diabetes if you know anything about diabetes. It also can be genetic. It runs in the family. My dad's side of the family has a history of diabetes. So therefore, I might have a higher chance of getting diabetes because of that. Right? These are all things that that could have caused that to happen. These are obviously called confounding variables. I wasn't studying them at first, but I should have been accounting for them. Right? All right. Help me out with these very basic and very easy examples and tell me if you can answer these questions. A researcher believes that exercise prevents colds. He randomly selects 100 people who exercise regularly and records the number of colds they develop throughout the year. At the end of the study, the group who did not exercise had significantly more colds on average than the group who did exercise. Okay. All I want you guys to do is tell me, why is this an observational and not an experiment? Same reasons, right? Same reasons as before. We just observed, we didn't apply any treatment to it. What is the explanatory variable? What are we manipulating in this particular semi-observational study? I'll go back. Let me go back. Oops. What's going to explain? What's the explanatory variable? What's going to explain the response variable? What are the variables in general? What are things that we're exercising? Okay, exercising, seeing if exercising prevents colds. So exercising is our explanatory variable, whether they exercise or no exercise. What's our response variable? What are we going to measure at the end? Whether you got sick or got a cold. Okay, that's our response variable. Still an observational study, but we still have explanatory and we still have response variable. Give at least one example of a possible confounding variable. Okay, what else could cause colds besides exercise? The weather. That's a confounding variable. What else? If other people are sick around you and you're exposed to them, that's a confounding variable. There's a ton of things, right? Maybe what you eat, maybe what you're allergic to outside. Those are all confounding variables, all right? So I'm just going to give you guys a bunch of examples here because these can be pretty easy, but I don't want you guys to get confused on these things. Let's see. A magazine wanted to find out whether taller people make more money than shorter people. Do you think that's true?
No.
You don't think that there could be an association between that? It's called, is it height? What is that? Heightism? If you discriminate somebody based on their height. They put a link in their magazine for people to log in and fill out a survey that asks how tall they were and how much money they made. What's the explanatory variable? How tall they are. Yep. That's how height of the people. What's the response variable? How much money they make. Good. You guys got this. This is pretty easy. Okay. It's not too hard. Another example. Doctors wanted to determine whether or not magnets relieve pain. Have you ever seen people do this before where they go to like a chiropractor or one of those quasi doctors and they try to use magnets on their backs to try to ease the pain or their back pain? So they set up an experiment in which patients with chronic pain were exposed to magnets while other patients were exposed to fake magnets. So they think they were getting a treatment, but they were fake magnets. Does anybody know what that's called? Placebo. Yeah, placebo. What's the explanatory variable here? The magnets and the fake magnets, so their exposure to them. Good. All right. What are we measuring? What's the response variable? The pain. Yeah, your pain level or relieve the pain. So that's something that we can measure. We can measure pain level, right? You go to the doctor, they ask you, you're sick. It's like, what's on a scale of 1 to 10? How much does it hurt? We can still measure those things, right? I think it's the last one. Some people who race greyhounds. Anybody have a greyhound? Seen a greyhound before? They give their racing dogs. What's his name on Simpsons? Santa's Little Helper. You ever watch Simpsons? Never watched The Simpsons? It's been on for like 30 years. Investigators at the University of Florida tried 3 different diets in random order on each of the 5 racing greyhounds. They were surprised to find that when the dogs ate high amounts of vitamin C, they ran more slowly. Okay. What is the explanatory variable? The diets of vitamin C. And then what's the response? What are we going to measure? How fast they run. Okay. Easy. This is easy stuff. You guys got this. Oh man, I have one more. Okay. An experiment was done by medical researchers to determine the association between drinking caffeine and the severity of lung cancer. 100 subjects were studied over a 20-year period. Results showed that there was a high association between caffeine intake and the severity of lung cancer. I think this is the last one. What's the explanatory? Drinking caffeine or caffeine intake. What's the response? If they got lung cancer, and more specifically, how severe it was if they did get it, right? Again, we can measure that stage 1, 2, 3, 4. If you've ever heard of cancer, those are all measurables. Okay. Remember, this will explain this, not the other way around. That's the easiest way to remember. Okay. What are some possible confounding variables? In other words, what else could cause lung cancer besides just caffeine? Smoking is probably the biggest one, obviously. That's probably the one that everybody would think of. Smoking causes lung cancer or can cause some lung issues. All right. Genetics, health, there's a lot of things that might go into that. Okay. All right. So I'm going to give you guys a few vocabulary words. I'm going to go through them pretty quickly because they're pretty easy to remember. When we talk about doing an experiment, we're doing an experiment on people, they're called subjects. You're all my subjects. My experiment is, do you pass the class? Right? That's my experiment for the year. If it's not a people, if it's not a person, it's experimental units. If I'm doing an experiment like on plants, they're just called experimental units. Okay. Subjects are only for people. Treatment is all the combinations of the explanatory variables that I do together. Let's say, for example, I wanted to see how much sleep and music helped you with that test next week. So I put some of you sleep for 6 hours and listen to music. I let some of you sleep for 6 hours and not listen to music. And then I have some of you sleep for 8 hours and listen to music, and some of you sleep for 8 hours and not listen to music. Okay. The explanatory variables are the sleep and the music, but my treatments are all those combinations, those 4 different combinations of treatments that I could do together. So I'll give you 2 examples of that, and then we'll pretty much be done. So here's an experiment that was run a while back. They wanted to investigate the effects of repeated exposure to an advertising message. If you've ever seen commercials on TV, you've all seen commercials. Before the commercials come out on TV, they get people in a room, okay, and they watch these commercials. And they don't just watch the commercials by themselves. Sometimes they do, but sometimes they implant the commercials in like a 30-minute episode of a TV show, and they make these people watch the entire TV show with the commercials in there, and then they ask them about the commercials after the fact. Do you guys know how this is how they do it? Because they want to make sure, they want to know how much you're actually going to remember that commercial. If you just watch the commercial, that's it. But if you're watching a commercial while you're watching an actual TV show that you like, that's where they really, really trying to get you guys to remember. So this is what they always done. They had 60 students viewed a 40-minute television program that included the ads for a digital camera. Okay. Some subjects saw a 30-second commercial, while other subjects saw a 90-second commercial. And then the same commercial was shown either 1 time, 3 times, or 5 times throughout the episode. After they viewed the entire episode with the commercials in it, they were asked questions about, did they remember the ad, and do they want to purchase that digital camera? This is obviously a while back. Do you guys even buy digital cameras anymore? You'll just use your cell phones, right? Like our cell phone quality cameras today is way better than my first digital camera back in like when I was in high school, or I think I was in college when I got a digital camera. Who are the experimental units or subjects? How many? 60. Are they experimental units or are they subjects? They're subjects. They're people. Yeah, 60 undergraduate students. Easy? All right. What is or are the explanatory variable or variables? Say it again. The amount of time of the commercial, so the 30 or 90, and what else? How many times they show it. All right. So there's a 30-second commercial and a 90-second commercial. So the length of the commercial and the number of times that they show it. Those are the 2 explanatory variables. Now here's the big question. How many treatments are there? There's 2 explanatory variables, but how many total treatments are there? Remember, treatments are every combination of explanatory variables. Once you see it, you're going to be like, oh, I get it now. Who said that? Why 6? Yeah, there's two commercial links, and there's 3 different ways they can watch it. Watch this. So you have 6 different ones. You have the 30-second commercial 1 time, the 30-second commercial 3 times, and the 30-second commercial 5 times. And then you have the same thing for the 90-second commercial. That's the number of treatments. That's how you figure out treatments. So 2 explanatory variables, but there's 6 treatments because there's 2 links and there's 3 number of times that you can do it. Make sense? You'll see it pretty easy on the next example. And what's the response variable? There's actually 2 of them. There's 2 of them this time. It's in the last sentence.
They wanted to purchase it.
Yeah, they want to buy it, and if they remember the ad in general. So they're measuring 2 things: how much they remembered it, and if they wanted to buy it. Easy or hard? Pretty easy, right? All right, I think this is the last slide. I'm going to do one more example of this, and then I'll give you guys your assignment for that. Oh, actually, no, I take it back. I have one more thing. Tortilla chips are made from frying tortillas. Anybody ever make homemade tortilla chips? Good. And obviously they're best when they're crisp and not soggy. There's 100 tortilla chips from the same batch are used to determine the best frying time and temperature for an ideal tortilla chip. Tortillas will be fried at either 150 degrees or 250 degrees for either 45 seconds or 60 seconds. And then the moisture content of each chip will be measured for crispness. How do you measure crispness? No. What are the experimental units or subjects? What am I doing the experiment on? The 100 tortilla chips. Are they experimental units or are they subjects? They're experimental units. Subjects are only if they're people. All right. What are the explanatory variables? Okay, so what is that overall called? Temperature. What else? The time. Okay, the time that we're gonna fry the chips, the tortillas, really, I should say. They start out as tortillas and then become chips. How many treatments are there? Just 4. Kevin, what are they? What are the 4 treatments? There you go. 150 for 45 or 6. 150 for 45 seconds. 150 for 60 seconds. 250 for 45. 250 for 60. 4 treatments. What's the response variable? Moisture content, the crispness of the chip. Either one. I think they were both being measured, right? Easy. Okay. When you're running experiments, you need to have 3 things to have a good experiment. Got to have a control group. Okay. A control group doesn't get any treatment at all. So if I was, again, testing you guys next week on your test and whether or not sleep or music helped you your test scores, I need to have a few of you in my control group. What would the people in the control group not do? They wouldn't listen to music. And they probably just get a normal amount of sleep, whatever they normally do. All right. I don't tell them, hey, you have to have 8 hours or you have to have 6 hours. Whatever your normal routine is, you do that. That's my control group. We need to randomize it. I don't want to just pick certain people to be in one group and certain people to be in the other group. I need to randomly select you guys for one group and randomly select you guys for the other group. If I don't do randomization, what can happen? I could be biased. If I put the 2 best students in the class in the same group, well, that's going to bias that group a little bit because I put the 2 best students in there. All right. Or in all of my classes. I need to make sure I randomly do it. And then Ruben mentioned this earlier. Okay. Hey, we need to make sure that we do our experiment enough times. Is 50 people really enough? Is one time really enough times to do this, to do my experiments? You want to replicate it over a lot. If any of you watched that video, how many of you watched the 5.3 video already? We mentioned the replication process in there. Right. Raise your hand if you watched it already. Okay. What did they say about the replication process? Why do people not do it? It's expensive and nobody gets notarized. Nobody gets notary out of it. Right? Nobody gets recognized for doing an experiment that's already been done. Okay, even though that's a big part of the scientific process. Okay. Last video. I think this is the last thing.
In this video, we will be talking about the placebo effect, control groups, and the double-blind experiment. A placebo is known as a fake treatment.
Homework, so just watch this.
It could be known as a fake pill, drink, lotions, or any type of treatment that is known to have no medical effect. However, a placebo may have psychological effects. These psychological effects are known as the placebo effect. By believing and expecting something to work, it will work. For example, if you believe that a pill will make you feel better, then it will make you feel better, even if the pill is fake. In other words, the pill is a placebo. If you think that the same placebo will make you feel sad, then it will make you feel sad. This is the placebo effect. Placebos can be used for a control group. The control group receives the placebo as a treatment. In other words, the control group receives a fake treatment. Now, why would you want a control group? A control group gives you something to compare your results with. So suppose an unknown company were giving pills to people at the gym to help them gain strength. After 1 month of treatment, 75% of the people taking the pills report that their strength has increased. Does this mean that the pill was the cause? No. So far, this is an observational study. We cannot say for sure. Maybe there are lurking variables that are present, like diet and the type of workout routine. Some people may have better diets or workout routines, which may have allowed them to become significantly stronger than everyone else. This is why we need a control group. We could randomly assign participants into 2 groups. One group will be the control group, and the other group will be the experimental group. Each group will have to get the same thing. So each group will receive the same diet, each group will have the same workout routine, and each group will get the same amount of sleep, and etc. The only thing that is different between these two groups is that the experimental group receives a pill and the control group receives a placebo. A good placebo should look and taste like the actual pill. If the percentage of people in the experimental group significantly gain more strength than the people in the control group, then we can say that the pill is actually the cause for gaining strength. You can think of the control group as just doing nothing to it. We have the placebo for humans because we can perceive things psychologically. If instead our experimental units were plants, which lack a nervous system and the ability to perceive things psychologically, then we don't really need a placebo. So the experimental group of plants receives the treatment, and the control group gets absolutely nothing. And then we would compare the results from the experimental group and the control group. Going back to our first example, if the control group knows that they are receiving the placebo, then this will obviously eliminate the placebo effect and it may skew the results. We need an equal playing field where neither group knows if they got the placebo or if they got the actual treatment. To prevent bias in the manipulation of results, the experimenter should also not know which group is which. This setup is called the double-blind experiment, where the experimenter and the subjects do not know which of the groups being studied is the experimental group and which of the groups is the control group. The double-blind experiment is good for eliminating biased research results.
Have y'all done that in science classes before? You know what a blind experiment? So obviously we don't want, if we're doing an experiment, we don't want the placebo, the control group to know they got a placebo. If they know they got a placebo and we're doing an experiment on the study of like that strength pill, then of course they're gonna know it's not gonna make them stronger, right? But if somebody takes a placebo and they actually think it's making them stronger, even though it's not, that's called the placebo effect. But we want that to happen. We want to know as the experiments are running, who has the experiment, who doesn't. They shouldn't know if the people that are doing the experiment don't know which group they're in. That's called a blind experiment. But if I'm running the experiment and I also don't know who is in each group, that's called a double-blind experiment. But if I don't know who, then who ultimately knows? Who has to find out? There has to be like a third party, somebody that's not doing an experiment at all. There's a third party that knows this is the control group, this is the treatment group, and they'll let the experimenter know who is in each group after it's all done. The reason why I don't want to know, the reason why the person running the experiment doesn't want to know who is in, because, hey, if I'm questioning you about, hey, how did your workout go? I can press you guys. If I knew Noe got the actual, good non-placebo, he got the strength stuff, and he's like, I don't think it's really working. And I'm like, are you sure? You sure it's not working? I could change my questioning and that would cause bias, right? That would cause a lot of bias. All right. So your assignment, oh shoot. I still have stuff on here. God dang, this is a long one today. I think I broke it up into 2 class periods last year. That's why. So help me out. Help me figure out from the 3 principles of experimental design. Help me figure out what the problem with these studies are. In order to test the effectiveness of nicotine patches, Dr. Hurt recruited 240 smokers at various locations. Subjects received a 22 milligram nicotine patch for 8 weeks. Almost half of them had quit smoking at the end of the study. Does this prove that the nicotine patch is an effective treatment to stop smoking? Yes or no? No. You just had the nicotine patches. Some of them got a 22 gram nicotine patch for 8 weeks, and then some of them didn't. And almost half of them who got the patch had quit smoking. What's the flaw here? You got 240 smokers, and they gave them all the nicotine patch for 8 weeks. Almost half of them quit. What's the flaw? What did we not do? What should he have done? Should everybody have gotten the nicotine patch? No. We need a control group, right? What should the control group have gotten? Not nothing. A fake nicotine patch. Yeah, we should have had a fake nicotine patch. There is no control group. We got to have a control group, fake nicotine patch. What's that called? Placebo. And then compare the results. Because now we don't know whether or not they just wanted to quit it on their own or not. We need to be able to tell if the nicotine patch is actually working. There could have been other things that had caused them to quit on their own, especially if they wanted to quit smoking at get go. Okay, so control group. Remember, got to have a control group. So he tries to fix his experiment, and this is what he did. He recruits 100 smokers. The first 50 to sign up receive a nicotine patch for 8 weeks, and the last 50 to sign up receive a placebo patch. By the end of the study, 56% of the subjects in the treatment group stopped smoking, while only 23% of the subjects in the control group stopped smoking. What's still wrong with this problem? What's still the flaw? You had the first 50 people to sign up this nicotine patch, the last 50 people got the placebo patch. Why is that still bad? So if you're the first 50 people to sign up for this thing to quit smoking, what are you more likely to be?
The one that wants to.
The ones that want to really smoke or quit smoking, I should say, right? If you're the first 50 people to sign up, they might want to quit smoking more than the last 50 people that sign up. So what should we have done differently? Put it out randomly. And once we have all 100 people, we randomly put them into the treatment group and then the control group. Okay, we've got to randomly do this. That's the second principle of good experience: control group, randomization. Okay, got to have both of those things, as well as the third one. So last example, he recruits 10 smokers to participate in his study. He randomly assigns 5 of the subjects to a nicotine patch and the other 5 to a placebo patch. At the end of the study, 3 out of the 5 in the treatment group stopped smoking, but only 2 out of the 5 in the control group had stopped smoking. Here's your answer from earlier, Ruben. What's wrong with it now? We got a control group and we randomly did it. What's the problem now? You said it earlier. It's only 10 people, right? We got to replicate this. We got to do this over and over again. Okay. This time the problem was it's too small. You can still do small examples like this, but do it over and over again. That's the replication process. Okay. Replicate it over and over again, or get a much larger group to experiment on. Control group, randomization, replication. Those are the 3 things you need to do to have a good experiment. And I'm finally on the last slide. All right. Okay. You guys, your assignment's posted. It shouldn't take you very long. It's all on one page. It's all on one page, but write it in your journal. You can get a copy of it here so you don't have to pull it up on Schoology, or you can pull it up on Schoology there. And then you guys have until Thursday to finish that one. Thanks for logging in today, Richard, as the only person at home.